Welcome to Right Triangles and Trigonometry. In this unit, we will look at solving for missing side lengths or angles in a right triangle, or even multiple right triangles, using trigonometry. So we'll start with right triangles. In this video, we're going to review the Pythagorean theorem, as there will be examples that come up throughout the unit where the Pythagorean theorem will be helpful. Now, the Pythagorean theorem states that the area of the square, whose side is the hypotenuse, is equal to the sum of the areas of the squares on the other two sides. So in other words, a squared plus b squared equals c squared, where a and b are the two side lengths, sometimes referred to as legs of the triangle, and c is the hypotenuse. Now, A and B can be interchanged, but C has to always be across from the 90-degree angle, and will always be the longest side. Now, we use the Pythagorean theorem in examples where we're given two side lengths and we're looking for a third one. Like in example 1. We have to determine the missing side length in each diagram. So here the missing side length is across from the 90, so we'll label this one C, this one A, and this one B. So now I'll just plug those values into my Pythagorean theorem. A is 6, B is 8, now 6 squared is 36, and 8 squared is 64. Adding those together, I get 100. Now 100 is the value of c squared. In order to get what c is, I just need to find the square root of 100. And the square root of 100 is 10. So c equals 10 millimeters. Now for b, I'm not looking for c this time, because c is here. I'm looking for a. So I'll fill in my b to be 2 and my c to be 7. Working that out, I get a squared plus 4 equals 49. Now this one's a little bit different than a. What I'm going to have to do here is subtract 4 from both sides, because I'm trying to isolate a. So if they cancel, I get a squared equals 45. Now it's similar to the last one in that I again do have to find the square root. And the square root of 45 is going to give me a decimal. So I'll round that off to 6.7. So A is 6.7 centimeters.